Essentially, what we mean by piecewise is it could be even more general than that. It doesn't have to be about business. It doesn't have to be a business application. Often things are related to business are piecewise. But what we mean by a piecewise function is that you use different rules for different parts of the domain. See, I'm still standing in your way, aren't I? That's really, it is tricky there.
A equals PRT, what was that relevant to?
A equals PRT. That sounds like, I think that's actually a simple interest formula. The amount in your account after a year of interest is principal times the rate times the time, if it's simple interest. In other words, piecewise defined is something where we're defining the function in separate pieces. We have different rules for different parts of the domain. Now, I wanted to start you off with just an example, like just so that you could have some idea about what I was talking about. Lots of things that when you look at pricing schedules, you usually get a break if you buy more than one thing, right? Or buy lots. So if you made a lot of copies, so here at Quick Copy, you pay 5 cents a piece for the first 100 copies, but then the rule changes if you buy more than 100 copies. So in other words, you don't pay 5 cents for any number of copies that you make. If you make more than 100 copies, the rule changes. So that's an example of a piecewise defined function. Okay, that's what we're after here, is that the rule changed. We got n as the number of copies. If n is the number of copies, then depending on how many copies you get, the rule for calculating how much it costs changes. Okay, so let's see what this will end up looking like. If the number of copies is less than or equal to 100, what's a way to write that symbolically? If I let n be the number of copies.
N equals 100 times 5?
Well, just right now, that's a way to write what I wrote here in words. The number of copies is less than or equal to 100. That's the way to write that. Would you agree? Okay, that's n less than or equal to 100. If we had that situation, then to get the total price, so if I had 75 copies, the total price is going to be 5 cents times 75. The total price here is going to be 5 cents times n, whatever n is. If n is less than or equal to 100. So here's what we say verbally. We say this: if the number of copies is less than or equal to 100, then to get the total price, we multiply 5 cents times n. But the rule changes if we have something that's more than 100. Right? We have a different rule. So we're going to go to that page next. Everything okay so far? All I'm really doing is we're just kind of talking it through so that when we see it written algebraically, symbolically, it'll make more sense to us. So I'm just trying to show you kind of a real-life example of where these things come from.
Is there any way you could go back to the definition of piecewise?
Okay. Okay. There's the piecewise definition again. So this is an example of a piecewise defined function because the rule is going to change depending on how many copies we buy. The function is specified in pieces. And lots of times, I don't have these particular slides, but lots of times I have some things, so you don't have as much writing to do. I'll make copies of stuff.
Are these slides also showed on the internet?
It's exactly, and you can also print these from the internet. So that's one thing too that can kind of help reduce how much just note taking you have to do. You know, that way you can. But I also try to, since you guys are the on-campus students, I'll try to bring copies for you. So that's what we're. Yeah. So, okay. Yeah, every slide that I make, all the writing I do is all shown on that presentation on the internet. So, but now let's write this. But if the number of copies is greater than 100, so how do we write that symbolically? N 100. Okay. If n is greater than 100, now what are we going to do to get the total price?
2 cents per copy.
For all of them?
The ones over 100.
The ones over 100. Right, so we're going to have to pay 5 cents for each of the first 100, right? So there's the $5 flats fee that we're going to have there. We're going to pay the 5 cents for the first 100. And then we're going to have to add to that 2 cents times the number of copies over 100.
N minus 100.
That's right.
Times 2 cents.
That's right. Did y'all see that, where he came up with that? Because I need to have what I need to put in here to multiply by 2 cents. Well, you know, we could just do a for instance, if I have 180 copies, then I get charged 5 cents for the first 100 and then 2 cents for the remaining 80, which would be 100, or 180 minus 100. So what's going to have to go in here so that I can take care of that rule in general is n minus 100. Okay? So that can simplify some because that can look like this. $5 automatically times 2 cents times the number of copies over 100. So what that ends up looking like is it ends up looking like this. The price for n number of copies, let's make a function out of it, is equal to 5 cents times n in the event that n is less than or equal to 100. And it's this other rule, 5 plus 200ths times n minus 100 if n is greater than 100. So it has, that's what you will see. In other words, this is kind of the format for that piecewise function. That's how you see them. When you see them in the books, they look like that.
So you would put in the $5 instead of overlaying the 5 cents in? I guess because it would always be 100.
It's always
gonna be
that's
$5.
right. It's always going to be $5 here because it's always going to be 100 times the 5 cents. When it's over 100, it's always 100 times the 5 cents plus the number over 100 times 2 cents. So that is the way we could write our pricing function mathematically. Okay. So what I'll be interested to find out, Jamie, is can you get your calculator, your computer to graph that for you? You can. There's probably some ways about doing the how you have to tell it. The first rule, the second rule. First rule only applies when x is less than or equal to 100. Second rule applies.
You have to do them over, you know, like y1, y2.
Right. You're right.
You do that, and then you graph it, and it'll
That's true. That's how it would work for you. Yeah. Okay. So what we're going to be looking at is, oh, and I just erased it. The 100, one thing that we had on the next page I was going to tell you about is the 100, let's write it again here. This is what it looks like. Less than to 100. And it's 5 plus 2 cents times n minus 100. If n is greater than 100,
does it show what you're writing in, too?
it shows everything. That's why this piece is so important, because this interacts and it keeps everything. That 100 we consider the break point because that's where the rule changes. Okay, so when you look at a piecewise defined function, you think, okay, well the rule is this for these numbers. Look to see where the break point is, and it's this for the rest of the numbers. So the break point here is 100.